Hey folks, welcome to Lab 7's tutorial. All right, a couple things. I have the Lab 7 manual open. Excuse me. I'm going to go ahead and open up Lab 7 that I had started in class on Monday. Um, you should be able to download your data and organize it in a fashion that you've been doing for the last bit. Um, excuse me. I'll go ahead and share my screen so you can see what I'm doing. So right now I'm just opening up Lab 7. Excuse me. I have already attached the data um, to the file. So in the folder over here on the right, you see we have Lab 7 data. These are all shape files here, and then you have two TIFF files, which are rasters, and then a layer file. So up here in the database, you want to make sure all your shape files have been inserted. In order to insert the rasters, you have to use a different tool. So you're going to go to geoprocessing. You will do raster to geodatabase. And then from here, you will navigate to those TIFF files. Let's see. Folders, labs and data. You will grab these two TIFF files. You will input them and make sure your output geodatabase is your Lab 7 geodatabase. All right. Once these are processed in here, you can go ahead and add these files, to the contents pane if you'd like. The next step in our lab manual is to go to your folder, grab this layer file, and add to current map. And what you see immediately is a red exclamation point. So that means that something's broken. So we're going to right click. You're going to open up the properties tab and go to the source. You're going to want to set the data source. You're going to go to your lab. Sorry, just to get to the right spot here. Go to the data, and you want to set your source to the LC chit. Okay. And then you can click apply. Okay. And now you will see that land cover populates with the right data. Go ahead and save your work when you do that. So I've gone through, the first part, right? We went through this in class, but you're going to add all of these to your files. You're going to import your shape files to the geodatabase as well as the rasters to the geodatabase. You're going to create a shaded map of Richmond. So we need this layer file. You want to go ahead and make sure you attached the LC chit raster to your data size. How do you figure out if the cell size of LC chit and dem chit are equal? Don't forget that we look at the properties of the rasters to see their cell sizes, right? So you can go ahead and do that. So the study boundary for today's lab is Richmond, Vermont, the town boundary of Richmond. And you're going to create a 2 kilometer buffer around the polygon. And then we'll save that as a new layer called Richmond buffer 2 kilometers. So let's do that quickly. We're going to go make sure we have Richmond boundary. Cool, it's down here. We want to create what did it say to do? Create a 2 kilometer buffer around that polygon and then save it. So if you don't remember how to do that, you can go back to lab 5 or 6, I think it is. So I want to create a buffer. That's a tool. I'm going to go back here to geoprocessing. I'm going to figure out buffer. Doopity boop. Buffer, not 3D. We're doing regular buffer. Okay. I'm going to open this up. The input feature is the Richmond boundary. Okay. Because that's the town boundary. The output feature class, remember, we're going to call it Richmond boundary, I think 2 kilometers, right? If you don't remember, like me, my brain goes back and forth. Yeah, underscore 2 kilometers. Okay. It's kilometers, so you're going to want it to be kilometers, distance of 2, going to dissolve that for now because it's just one thing. And you're going to run it. Why did it do that? It's so annoying when it doesn't name it properly. Okay, so that's obnoxious. I'm going to go back because I don't want it to mess with my stuff here. I am going to create one that says, like I want it to, 2 kilometers. Sorry for the sound. I have to pick up a friend from the airport. Okay, so 2 kilometers, output, Lab 7 geodatabase, run. Why am I redoing that? Because I want to not lose it. So I'm going to remove this one. I'm going to go to my catalog. I'm going to get rid of the weird one that says just buffer on it. Delete. Where are you? There we go. Okay. The reason I do this is because it keeps my brain working properly. So I can turn off the old Richmond boundary. I can turn off land cover. Now I have this buffer. Okay. Should I save? Yes, I should save. So now I have a 2 kilometer buffer around the Richmond boundary. What am I supposed to do next? So before proceeding any further, you have to specify your environment settings. So this is something that I started to show you in class, but I'll go ahead and walk you through it. So we're going to go to the analysis tab and go to the environments. Okay. Under processing extent, we're going to set that to the Richmond buffer. All right. So I'll show you how to do that. So analysis tab, environments. We want to go to processing extent here. If you do XY, no, extent coordinate system, no. How do I do that? Oh, I do this little drop down and I pick Richmond boundary 2 kilometers. It automatically pops all the X and Y extent and puts the coordinate system in there for you. All right, go ahead and click OK. You're going to want to click Save. If you're not sure if you did it correctly or not, you can go back to environments and look, it pops it up right there. Okay. This is something you need to remember how to do because you have to go back and do it a bunch. You can also always look up through the extent properties. Okay. Basically what this does is it creates bounding coordinates. So it makes it so that everything is going to go into this coordinate section. So next we want to set the cell size of the Likchit as seen below. So you're going to go to the raster analysis part. So we're going back here. We're going to go down to the raster analysis part. The cell size is, let's see, same layer as land cover because that is the LC chit. Oh, really? We're doing maximum. Okay, fine. Maximum, convert, and default. Fine. Maximum, convert, and default. Cool. Okay. What else is it wanting us to do? Why are we doing this? It's set to the grid size for all the data derived from the project, while the mask specifies the region within which the data processing occurs. Data outside the mask will not be processed. We're going to set mask to Richmond buffer 2 kilometers. So go back here, go to mask, and you're going to navigate to your Richmond boundary 2 kilometers and put that in there. Also set the snap raster to LC chit. And what that does is make sure that any of the data sets, any of the rasters will align with this land cover data. Okay. And you click the yellow folder and browse for LC chit. So let's go back here to snap raster, click the folder. Oh, name LC chit. Let's see if that works. Okay, fine. Sometimes weird things pop up. You can just click through it. Sometimes it doesn't. Make sure that this is set to the LC chit raster in the Lab 7 geodatabase and not the land cover TIFF file in the download folder. Okay, so I'm going to click here. I wonder if what work was lost. Shoot. Okay, so I'm going to go back really quick because something's going on with my internet. I'm not sure what got, what you can see and what you can't see. All right. So I have walked through raster analysis, maximum inputs, convert units, under masking. I use the drop-down to select Richmond boundary 2 kilometers, cell alignment is default, snap raster. I went searching for Lab 7 geodatabase LZ chit. Okay. So then click OK to finalize your environment settings. Great. So click OK. I am going to save my work. Do a lot of saving in this lab, please, 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 please. Just so that you don't have a horrible time, basically. All right. So take a screenshot of the environment's interface and store it. That means this thing, this environment's interface. Take a screenshot of this. Make sure this is open, otherwise you won't get full points for it. All right. In the lecture, you learned about several surface analysis tools contained in the toolbox. You can look for them in the toolbox, or you can just search for them by name. We're going to start with hillshade. Recall the hillshade is basically the shadows for the terrain, right? The hillshade is only for display. You can drape any raster or vector data set over the hillshade, and you create this cool like 3D effect. So you're going to do that, all right? We're going to go ahead and go to geoprocessing. You can just type in hillshade. Okay, it pops up right there. So there's a couple of them. Which one do we want? We want to use spatial analysis tool, hillshade. Okay. So there we go, hillshade. Okay. And what we're going to do is set the input raster to dem chit and name it Richmond hillshade. So not that. So we want dem chit. So you have to go navigate to it. Dem chit. And instead of it being called something weird, hillshade. Is that what we're calling it? Richmond hillshade. That's right. See, if I click off of it, it does weird stuff. Richmond. Let's spell it properly here. Richmond hillshade. Okay. Make sure that stays. I'm gonna leave this, whatever, run. Boom. Thinking, it's updating. Cool. So now you have this cool hillshade. Again, I'm going to save so I don't lose my work because this is time consuming. What's the maximum value of Richmond hillshade? You can look that up in the properties. Okay. During the last step, you should have produced a shaded relief map of Richmond. Yep. Now let's explore how you can use this raster to alter the appearance of land cover data. So let's make sure land cover is on top of the Richmond hillshade. So we're going to grab this and move it on top, excuse me, of Richmond hillshade. I'm going to turn it on. Let's see. Now select the land cover data set in the contents pane. Yep. And then click on the raster layer tab up at the top and use transparency to change it to 40%. So raster layer, transparency. You can just type in 40 if you want. That works. Okay. Save. It's usually the fastest way to do it. We can play around with it too, obviously. The map should look a lot like this image below. Yep, it does. Except ours is blue, so you can just change this to be a black outline. And now it looks just like the lab manual. It's just symbology, okay? Cool, yep, it looks like that, great. So now we're gonna turn on the buffer. Yeah, it's already on. We're gonna change the feature layer symbology so it's only a black outline. Yep, we just did that. Now zoom to the spatial extent of the Richmond buffer and be sure that the raster layer tab is displayed at the top of the interface and that only the visible data are the Richmond buffer 2 kilometer land cover and Richmond hillshade. So that means that none of these other things should be showing. Just this one, and this one, okay? And it wants me to do the raster layer tab. Okay, so I'm going to highlight Richmond buffer 2 kilometer. Richmond Hillshade. Is that the one it wants? Hold on, let's make sure I'm telling you the right thing. Change to feature layer, zoom. Zoom to the Richmond buffer. Okay, so basically you're going to right click, zoom to layer for the Richmond buffer, okay? And then you're gonna highlight Hillshade because it's a raster layer, or you could probably highlight land cover too, that's fine. And see how it shows land raster layer up here, sorry, raster layer, all right? So make sure that you've got that going on so that when you take your screenshot, you get all your points. And then let's see what's next. To save disk space and increase the processing and analysis efficiency, you will clip the land cover and DEM raster datasets to the study area of Richmond, boundary 2 kilometer. Okay, so clipping a raster dataset is similar, but slightly different than clipping a vector dataset. Instead of using the clip tool, you're going to use something similar. It's called clip raster. Okay, so we'll go ahead and go back to geoprocessing and we're going to type in clip raster. Okay, then you can open up clip raster and your input rasters will be land cover and your output extent is going to be the boundary, 2 kilometer boundary. Okay, and you can call this, tell us what we want it to say. Name the output raster Richmond DEM for that one. And for land cover, Richmond land cover. Okay, so for this one, I want to make sure this is called Richmond land cover. Clip, and we're going to check use input features for clipping geometry. Cool, run. Once that's done, then we're going to go back up here and we're going to do Richmond Hillshade. Hang on, I gotta look at this and pay attention. Nope, I'm doing Richmond DEM. So I have to find Richmond D. No. Hang on, I'm getting ahead of myself. Okay, so then we do dem chit and the buffer, and then we clip it. Right, okay, so dem chit's not on there, so I'm gonna navigate to it. Dem chit, okay. My output is still the 2 kilometer Richmond boundary. This now needs to be called, this is supposed to be called Richmond dem. So Richmond, that's digital elevation model. Okay, make sure this is checked and run. All right, so now I'm going to turn off my old land cover and I don't have the other one in there. So now I have something kind of cool, right? So I have Richmond DM, which has all these interesting values, which is a digital elevation model, and I have Richmond land cover. Cool. I'm going to go ahead and save my work because, again, this all takes a lot of time. Okay, now the newly clipped Richmond land cover dataset was not rendered using the same symbology as land cover chit or LC chit. You can recreate the symbology manually, however, it's much easier to apply the layer file like we did earlier in the lab. So go to the raster layer symbology interface and apply LC chit layer to Richmond land cover. So how do we do that? We go to raster layer and we go to symbology. It's going to take a minute or 10. It doesn't like us right now. Symbology up here. Oh, that's something different, right? So we're going to, I guess we can do that. Unique values, import from layer files. So we're going to do it that way. Okay, so instead of doing regular symbology like this, because that would be manually, we would do symbology, unique values, and up here, I guess we can't do it this way. You're gonna click on the, once it opens finally, it's to load, it's a big file, so this is where I meant be very patient, okay? So once it loads these three little dots, we can select the I'll teach it, and then it'll look up properly. This is where you have to think about some like chill music in your brain because rasters take forever. Okay, so finally loaded. So I'm gonna go up here, I'm gonna click on the three, and then do I import from a layer file or a layer? Let's see what it says. It says to import from a layer file. That makes sense because it's the LRX file. So go to folders, we go to Lab 7 data, and we select the layer file and click OK. It auto populates this for you. Okay, it's really nice. See how it says all the values: brush, residential, coniferous. It's really important. Again, save your work because it's a lot of work. So now your Richmond DEM matches the land cover class properly. And see how it auto-populated all those nice names for you? Let's go ahead and click save. All right. So next, we'll go ahead and set the transparency of Richmond land cover to 40%. Let's do that. Richmond land cover, raster layer 40%, transparency. Okay, we did that. Click save. Zoom to the spatial extent of the Richmond buffer and turn all data except land cover and hillshade off. So, okay, my computer's so slow. So I'm going to turn off. We just want land cover and hillshade, so we're going to turn off that stuff. So we just have land cover and hillshade, right? And I'm going to zoom to layer, which we're already there. Cool. Ooh, that's pretty. It's like 80s. Oh, you're taking a screenshot. Make sure that we clip the roads now to the buffer and name it Richmond Roads. Okay, so last thing in this one is save. We're going to go to geoprocessing. We don't have to clip a raster. We're just going to do a regular clip because roads is, oh, wait a second. Where's roads? Is it here? Chittenden Roads. Oh, I just need to add it here. Just add it to the. There we go. Now go to processing, clip. Let's do Chittenden Roads. We're going to clip it to, again, that 2-kilometer boundary, and we're going to call it Richmond Roads. What this does is it allows you to work with large data sets, but only the pieces that you need. Okay, so go ahead and run that. It's going to create a new layer file called Richmond Roads, and you can turn off Chittenden Roads now. Come on. Okay, so it's a vector data set, so that's easy enough. All right, so part 2 is done. Okay, part 3. In this section, we are going to derive slope and aspect from the digital elevation model. I think what I'll do is stop here. Oh no, I'll just keep going. Okay, so find the slope tool. Let's see. Oh, we're going to insert a new map and rename it surface analysis. Okay, so map. No, insert. There we go. New map. We're going to call it surface analysis. You can slow click surface analysis. Cool. Save. What else does it want us to do? We did roads. Cool. Okay. In this section, we're doing slope. So find the slope tool. Again, you can do it this way, but honestly, I just type it in up here, like slope. It usually pops up. You get a couple options. 3D analyst. We're not doing that. We're using a spatial analyst tool. You only use 3D in 3D maps. Okay. So set the input raster to Richmond Dem and the output raster we're going to call Richmond Slope, and make sure the output measurement is to degree. So what we're doing is Richmond Dem, we're taking a digital elevation model and we are measuring slope. So Richmond slope, right? That's what it wants us to call it. Richmond slope, and we want to make sure it's degree. Output measurement is degree. We're going to leave the default value for the z factor, which is 1. Okay, and we're going to click 1, basically, not okay. All right, ooh, cool. Again, save it. Okay, now we're going to use the aspect tool to create the aspect layer, and we're going to name it Richmond aspect. So same thing with slope. We're going to go back. We're going to use aspect. Enter spatial analysis. Not that one. Richmond Dem. Call this Richmond aspect, right? Richmond aspect. Let's see, are there any other special instructions? Use the default. Okay, so click run. Cool. Dang it, did it not name it properly? Oh, that's so annoying. So annoying when it does that. Richmond aspect. Stupid thing. Run. It's worth going back and just rerunning it, because otherwise you're going to have to figure out what it is that you did randomly. So I'm getting rid of the incorrectly named things. Yes, go away. Ooh, that's cool. I'm going to click save. Looks like my slope one did the same thing. So annoying. Delete that one. Yes, get rid of it. It's ugly. I like it. It's not correct. Go away. Right click, remove. Okay, geoprocessing, and go back to slope. See how much faster things are when you do it the second time? Oh, note to all of you, this is on your exam, this kind of stuff. So make sure you make notes about this. Like not your exam, but you know, your final lab. You know, it's not really an exam, but it is kind of, you just have to do it by yourself, right? It's just a tricky, not mean tricky, but it is a tricky lab. Okay, so go ahead and save that. So now make sure you have Richmond slope and Richmond aspect. Awesome socks. So make sure you're making notes with this. Now we're going to change the raster layer symbology for Richmond slope using natural breaks with 3 classes. And we can always switch to stretch and then back to classify if it gets funky. All right, so Richmond slope, right click, symbology. We're going to do manual, and instead of 11 classes, natural breaks, do come. See, computers get mad. And we're going to switch it to 3. Okay, it changes. Ooh, that's fun. Fun. I'm going to click save. All right, let me look at what I'm doing here. All right, take a screenshot of the Richmond slope classification in the contents pane. That is this over here on the left. All right. And then you can also answer the aspect tool question. I'm going to go ahead and pause here and create a new video for part 4. Thank you for listening. Stop share and